Okay guys, in this video I'm going to talk about how to find the equation of the tangent line and normal line to a curve. I try to keep it short and practical for your final exam. Okay, let's go and do a very simple example and then we're going to do an exam style question together. Okay, so a function is given to you, equation of a function. Let's say y equals to x to the power of 3 minus 3x plus 1. This function is given. Okay, this is a question for you. Go and find equation of the tangent line, equation of the tangent line at x equals to minus 2, or go and find the equation of the normal line at x equals to minus 2. They are more or less the same questions. For normal line, you're going to do one further step. Okay, otherwise they are more or less the same questions. So if you know how to find the non-tangent line, you definitely can also find the normal line. So let's talk about what does visually mean to talk about tangent line and normal line to a curve. So let's say that I have the graph of my function. I'm going to show the exact graph to you later, but let's suppose that this is the graph for you. Okay, at point minus 2, so this is point minus 2, x equals to minus 2. The x value of this point is minus 2. Okay, there is a tangent line. So there is a tangent line here at 9, which is perpendicular, which is at this literally at this point is parallel to your curve, and there is one intersection, one common point between the line and the curve. Okay, so the tangent line and the curve, they have one intersection point, and we call this line tangent line. Okay, and what is the perpendicular line? This is the, let me show it with green. The green is the perpendicular line. Okay, so the question is asking you go and find the equation of the orange line and the green line to your curve. Equation of these two lines are what question is asking us to find. Okay, so there is a connection between the orange line and the blue curve. What is the connection? You have to learn this formula. If you learn this formula, definitely you can solve this question without any problem. The value of derivative at any given point, the value of derivative, the rate of change at any given point equals to the slope of the tangent line. The slope of the tangent line. Do you agree with me? This line has an equation mt x plus c. And what I mean by mt is the slope of the tangent line. Okay, so this line has an equation like any other line on the Cartesian plane. Okay, the slope of this line equals to the value of the derivative of the curve at x equals to minus 2. So let me rewrite the equation. F prime at point minus 2 equals to the slope of the tangent line. This is the key formula that you need to use. This is the formula that makes a connection between the curve and the tangent line. So if I ask you what is the connection between the tangent line and the curve, you're going to use this formula. Okay, you're going to use this formula. Okay, so there is a connection between the tangent line and the curve, and this formula helps us to make that connection. Okay, now the graph of the function is given to you, the equation of the graph. May I ask you, go and find the value of the derivative. I suppose that you have the formula, you know how to use it for ax to the power of n, power rule. Derivative is a n x to the power of n minus 1. So the value of derivative of this function is 3x to the power of 2 minus 3. This is the value of the derivative. This is the equation that helps me. This is the equation that helps me to find the value of the derivative. equation of the derivative. Okay, now which point we are talking about? X is minus 2. So f prime of minus 2 equals to 3 minus 2 to the power of 2 minus 3. Minus 2 to the power of 2 is 4. 3 times 4, 12. 12 minus 3 is 9. So what does it mean? In this equation, you can say 9 equals to the slope of the tangent line. Great. We did the first step. We know the slope of this line, y equals to 9x plus c. At this point, we need one further step to find the value of c. How can I find c? In order to find c, you need a point. You need a point to find the value of c. So, which point? Do you agree with me? This point here, I have the x value, which is minus 2. Is there any way I can find the y value? Maybe yes, because this point is on my curve. This point is on my curve, on the blue curve. Okay, so in the equation of the function, which is y equals to 3 x to the power of 3 minus 3x plus 1, y equals to x to the power of 3 minus 3x plus 1, you're going to go and put x equals to minus 2. So y equals to minus 2 to the power of 3 minus 3 times minus 2 plus 1, which is going to be minus 8 plus 6 plus 1, which is going to be minus 1. So I know that the y value of this point is minus 1. Now I'm going to go and plug this point. Let's call it point A. I'm going to go and plug in point A into this equation. So minus 1 equals to 9 times minus 2 plus c. If you go for numerical solve, or if you do it manually, c is going to be 17. So the equation of the tangent line is 9x plus 17. This is the equation of the tangent line. Okay, I'm going to show it to you. The green is your line, a curve. The red is the equation of the tangent line that we found, 9x plus 17. You can go and graph it on GeoGebra or Desmos, or even on your calculator, okay, to check your answer. Now, can we find the equation of the normal line? Yes. How can I find the equation of the normal line? Literally everything is the same. The only thing is that you don't need to do this step. You don't need to do this step. You have the point. You need to find this point, the coordinates of point A. However, what you know about the normal line is that the slope of the normal line is minus reciprocal of the tangent line. What is the slope of the tangent line? 9. So minus reciprocal. This is going to be the slope of the normal line. All you have to do for the normal line, you're going to go and say y equals to minus 1 over 9 times x plus c. Here you're going to go and put one more time the coordinates of point A, because point A is also on the green line. So it's literally the same process. The only thing which is going to be different is the value of a slope. You're going to go and plug in point minus 2 and minus 1. So minus 1 equals to minus 1 over 9 times minus 2 plus c. So c equals to 2 over 9, common denominator 9, so it's going to be minus 9 minus 2, minus 11 over 9. Okay, so the equation of the normal line is y equals to minus 1 over 9x minus 11 over 9. Let me go and check it on Desmos with you. Well, I don't have Desmos here and it's going to take time, but you can do it also at home on your calculator. Okay, can we do it on the calculator? Why not? Let's do it on the calculator. Okay, so what is the equation of the curve? Document or menu. Okay, I'm going to go and add graph. What is my graph? X to the power of 3. In fact, it's not 2, it's 3. minus 3x plus 1. This is your graph. Then I'm gonna add another equation, which is 9x, equation of the normal line, tangent line, 9x plus 17. As you can see, this is the tangent line, and if I go and find the intersection point, analyze graph, intersection, look, the intersection is exactly minus 2 and 1. Can I go and find the graph the equation of the normal line? Why not? Graph function y equals to control division minus 1 over 9 x minus 11 over 9. Okay, as you can see, the black is also the equation of the normal line to my curve. So everything apparently makes sense. Okay, this is the core concept of the normal line and the tangent line. Thank you.